Hello. Absolute value equations and inequalities. This is 1.6. So our question is, what is absolute value? This is simply the distance away from zero. So if we were to have a number line, and we had a positive 6 plotted on this number line, as well as a negative 6. We just want to know how far away each of these are from 0. And you'll see that both of them are actually positive 6 units away, because distance is always positive. So our absolute value symbols, these up and down lines, just mean that whatever is inside of them, after you have reduced within the absolute values, becomes positive. So when solving absolute value equations, we end up having two solutions. To get these two solutions, we split our equation into two parts. We have x minus 5 equals 7, and then x minus 5 equals negative 7. This takes care of our absolute value idea. We go ahead and add 5 on both sides, and we get x equals 12. Add 5 on both sides, and we get x equals negative 2. Now, it's sometimes hard to wrap your mind around the fact that you can have two solutions. So let me plug these back in so you can see. So I plug in 12 minus 5 into my absolute value original equation. Check to make sure that equals 7. The absolute value of 7 is indeed 7, so this checks out. Once again, we plug in negative 2 for x this time. And we get the absolute value of negative 7 equals 7. Now the absolute value of negative 7 is positive 7, so that also checks out, meaning we have these two solutions for our absolute value equation. We do the same thing for this one, we just split it into two parts. We have 5x minus 10 equals 45. We have 5x minus 10 equals negative 45. Go ahead and solve. So we end up getting x equals 11. And x equals negative 7. I'm not going to check this one. Those are our two solutions. This time you'll notice instead of just a constant on our equal side, we have a constant with a variable. We'll still treat it the same way, but when we have a variable on the opposite side of our absolute values, we need to check, because sometimes it won't work. Go ahead and solve for x. X will end up equaling 6. And x will equal negative 2. Oops. So we need to check these because we have this variable on our right side. So plug it back in to make sure you do the original. We have to have those absolute values in there. So we plug 6 into our x's. We end up getting 12 plus 12 within our absolute values equals 24. Or absolute value of 24 equals 24. And 24 does equal 24. That answer checks out. So this one's definitely a solution. How about if we plug a negative 2 in, though? Absolute value of 2 times negative 2 plus 12 equals 4 times negative 2. Negative 4 plus 12 equals negative 8. 8 equals negative 8. Does 8 actually equal negative 8? It does not. That means negative 2 is not a solution. The only solution to this one after checking is x equals 6. All right. Now, doing these problems with inequalities is basically the same thing. We have our original, 2x minus 1 is less than 5. And then our new one, to solve for our second solution, we flip our sign and we also flip our inequality. And then we solve. So I have x is less than 3 and x is greater than negative 2. We need to graph it. We have open circles because they are strictly less than or strictly greater than. X's are less than 3. X's are greater than negative 2, so where they overlap is our solutions. And last example here, same thing, split it out. When I flip my sign, I also need to flip my inequality. So x is less than or greater, or less than or equal to negative 5. And x is greater than or equal to 1. This time they are closed circles at 1 and at negative 5. We need x is bigger than or equal to 1. And we need x is smaller than or equal to negative 5. Alrighty, that is absolute value equations and inequalities.